Okay, great. So, hi everyone. My name is Alex Razim. I'm very happy to see you all and thank you for registering for our workshop, which is being organized in second time. The first time we organized it only for the TVS Science Collaboration of LSST, and this time we are doing this LSST-wide with some adaptations that are different from the first time. So today's session is Git introduction. Azalee Bostroem from University of Arizona kindly agreed to teach us this mini workshop because she has experience with this. And this is the workshop that is based on the carpentry's materials. So we are following the carpentry's code of conduct. So please be kind and inclusive and behave essentially. And if something is making you uncomfortable or if you notice some breach of conduct, please reach out either to me or to Azalee to let us know. So the carpentry is just a couple of words in case you don't know, is a non-profit organization that is dedicated to creating software training workshops and lessons for the academia fields, not only for astronomy, but for all kinds of science. And all those lessons, they are free. They are free to use by your own, and they are free for you to organize your own workshops. So if you consider that these workshops are useful, and if you have the energy, please organize your own workshops, share the knowledge. This is the purpose of this training. Our today workshop is going to have several instructors who are going to be helping you and Azalee when we are going to have collaborative exercises. This is me. This is, I think, Rachel, who already joined, Angelka Kovacevic, Sid Cheney, if he will have a bit of time to join, and Federica, who I didn't put here, but who will be also in the background helping us with her rich experience in managing software projects in astronomy. So there are some links for you to access if you want to have a look at the materials. And one important thing is if you are still not connected to the LSST Slack channel for our workshop, please do this. You should have been able, you should have received several emails with this link, and I will post it right away also in the Zoom chat. Please send, try to connect to it. Even if you won't be accepted right away, it will be necessary for you to have access to this channel, to post questions and to get quick coordination messages also for the next week. So please do this. And also call out thank you to the LSST Discovery Alliance collaboration, who are supporting the development of these workshops and organization of these workshops. I will post the link to these slides with the links to the materials for you to access it anytime. And as you might have noticed, this lecture is going to be recorded. So the record will be also shared with you and with those who wanted to attend this workshop but couldn't because of the time zones. Another thing is that after the session, I will send you a link to the feedback form. Please fill it. And even if you are leaving early for some reasons, it's totally fine, but please let us know at which stage, to which stage you reached and what is your opinion of these materials and of the workshop up to the point when you were able to listen to it. That said, the links to the slides and to the Slack channel, I will post it in a second. And that's what I wanted to say for today. Thank you for coming, and Azalee, the floor is yours.
Awesome. Okay. Thanks for that introduction. I think you covered just about everything, so we're about ready to dive in. I've put 2 links in Slack. One is to the full software carpentry lesson. We'll be covering most of this lesson, and you'll see that much of what we do is based in this. But there's a lot of explanation in there that is not going to be on my slides. So I'll be showing you slides. I'll be talking about things. Feel free to ask me questions at any time. I'm someone who's known for asking questions, so I'm happy to answer them. And if you're more comfortable asking questions in the chat or something, maybe for the helpers in the room, if you can let me know if there's something that should be addressed kind of universally in the group in the chat, that would be great. I think you can use the Zoom chat or the Slack chat, although I will say if you put it in Slack, then it kind of persists for time, whereas the Zoom chat is gone. So that can be a little bit nicer if you want to like go back and see how people answered a question. Okay, let's see. Is there anything else? I will give us, I think I'm going to try and maybe go an hour at first, but then we'll start taking breaks at progressively shorter and shorter intervals, because I know that like screen time gets to be a lot, especially as you're trying to digest material. So yeah, I'm a postdoc at University of Arizona. I'm an LSST DA Catalyst Fellow. So I'm, I guess, associated with LSST in that way. And I've been teaching for software carpentry for the last 12 years. It's where I actually learned version control. And I run these lessons at the AAS meetings as well. And so that's been a nice way to stay connected to the community. Okay, so with that, let me share my screen. I'm gonna share my whole screen. Okay, so I've put a link to these slides. You shouldn't need the link, but if you want to go back or you want this later, those will be up forever. I slightly edit them as things change with Git. The other thing I'm gonna say is I'm gonna be teaching you command line Git. There are a bunch of different GUIs and different command line interfaces to GitHub that you can use, but this is kind of the most basic universal one. Okay, so we're doing version control, which is a way of tracking your code or your documents or your notebooks or anything that you're doing. And the tool that we're using to do this is called Git. Git is kind of the base program on your local machine. It has nothing to do with GitHub. It has nothing to do with Bitbucket or any other kind of server. What we're going to do right now is fully contained to your local machine. You can do this anywhere. You don't have to tell anyone about it. Version control, it's a tool to track the history of your project. For me, it gave me peace of mind that I could always go back to different versions of my project without needing to worry about, did I save a version? Did I make a copy of the document? If you're working with other people, it also allows you to see who changed what. I maintain a pipeline, and I'm not the first person to maintain it. And so frequently I'm looking at it and I'm like, that's a weird line of code. I wonder who wrote that. And I can use Git to go and look that up. It can be individual. If you're not ready to collaborate with people, you want to just get comfortable yourself in Git, you can track the history of your own project locally on your machine. Or it can be collaborative. It can be something where you and a colleague are editing a piece of code, or you want to share the code that you've written once you publish your paper with the rest of the community. You want to make things available. And it's something that people can contribute back to if you choose to make it collaborative. This is kind of one of my favorite PhD comics, and really exemplifies, I think, an experience that I had working on like my master's thesis and before I discovered version control. So if you look at the comic on the right, you can see like, you think you're done and you're like, this is the final version. And then you realize there's something you need to change, and you're final version number 1, and then you have final version number 2, and things get kind of crazy from there. So as an individual, this allows you to fix or undo mistakes. If you make a change that you think you want to do and then you realize that actually broke everything, it's really easy to revert without having to do like undo or something like that. You could have closed the document, you can reopen it, you can go back to previous versions. You also put a message with every snapshot that you save. And so this allows you to say, what was done and why it was done. So you can say, that's a dumb thing to do. Why did I do that? And then you can, I remind me that, this was an issue I was solving. It also gives you a definitive final version because you have this whole history with different snapshots. Even if, as you will see later, we like branch off in different directions, you can see exactly where everything is and which the final version is. It also makes things really hard to accidentally delete. Git, even when you go back, really likes to make that backwards motion a new snapshot rather than erasing everything that's in front of it. So for that reason, it's hard to accidentally delete something, even if you're combining things from a collaboration. So this is also helpful if you can imagine, like, you have, let's say you have like your final version and then you have your final 2 version and you end up making changes in both files. It's actually trivial to merge those changes in Git. Whereas, I don't know, for me, I'm like, oh, do I remember exactly which lines I changed? What if I forget something? Am I diffing these things? All of that. Git just makes that a lot easier. It also allows you, if you're collaborating, to know who to ask if you have questions. You know, why did you make this piece of code this way? It allows you to work simultaneously with someone. So you can be working on a piece of code, someone else can be working on a piece of code, and you can merge those versions together. You don't have to worry about overwriting each other's work. Again, it's very hard to overwrite things. So I'm hoping that gives you a sense of why you might want to use this. You're all here, so I think maybe it's not a super hard sell. So the first thing that we're going to do is we're going to configure Git so that Git knows who you are, and we're going to set a couple of defaults. If you open up a terminal, I'm on a Mac, so I'll be using a shell. Do I have any Windows users here? Should have thought of this before. Can you raise your hand if you're on Windows? Okay. Bias, am I saying your name right? People on Windows, let me ask this question. Do you have a shell that you can use Git in? Have you used Git before? Maybe you can unmute and talk to me.
Yes, there is a shell that we can use to like access Git. You just open Git bash.
Yes, so Git bash is what we use, but that doesn't come native on Windows. So that's why I want to. You can definitely download it and install it, right?
Yeah, yeah. You can also use it from the command prompt itself, if that helps.
Yes.
So
okay.
Windows plus R, and then you type in CMD, and that opens the command prompt for you, for whoever is using Windows.
Okay, so it seems like maybe this isn't going to be an issue. So open up whatever you would use for Windows or for Git. If you're on Windows, it's probably Git bash. If you're on Mac, it'll be terminal shell. If you're on Linux, it'll be whatever shell you're using. And then these are things what we're going to configure is we're going to configure globally. So this is for your entire machine every time you use Git, and you only need to do this once. If you don't want to do this globally, if you just want to do it for like the one directory that we're in, let's make a directory, and then you can drop the -- global. Let me see if that's going to work. No, let's. Okay, so sorry, I'm going to take a step back. Okay. I'm going to slightly change the order so that you don't have to do things globally if you don't want to. Okay, so the scenario that we're going to look at, just to have a situation to be in, is we have Dracula, Wolfman, and the Mummy, and they're all thinking about leaving Earth and going to a different planet. And so they're doing research on different planets, and they're going to share their research with each other. So you'll see this kind of overarching storyline informs the different files we create. So what we're going to do is we're going to create a repository. So the repository is kind of the overarching directory that all of your history and your whole project lives in. I think by default, we're just going to make it in your home directory. The big thing is you don't want to make repositories within repositories. So if you're in a directory that is already a Git repository, you don't want to make a new Git repository. So if we do this in our home directory, it should be not an issue. Okay, so if I type pwd, I can see I'm in my home directory. I'm going to make a directory called planets. I'm going to cd into planets. I'll type pwd just to make sure that I'm there. And then to create, and let me just type ls-a so you can see there's nothing there. To create a Git repository, you type git init, and that initializes this as a Git repository. What this means in practice is that it's created this .git directory. This is where Git stores its whole database of tracking the project history. If you ever wanted this to not be a repository, you just delete this .git directory, and then it's no longer a repository, it's just a normal directory. But this is not a directory you should ever need to go into. And you really, in general, don't want to mess around. But if you're ever curious, am I in a repository, you can always do this ls-a and figure out if it's a repository or not by looking for this .git directory. So now I can type one of my favorite commands, which is git status. So this just says, where am I? So it says I'm on the main branch. We'll talk about branching in a couple hours. It says there's no commits. We haven't saved any snapshots, and there's nothing to commit. We haven't made any changes. There aren't any files that it's tracking. So you may have noticed that the structure that I'm using is git and then a verb. So this is how Git knows you're talking to it, is you type git and then whatever you want to do. Okay, so now that we've done that, let me actually take a quick step back and ask, are there any questions? How's my font size in terms of being able to read my terminal?
All fine for me.
Okay, awesome. Okay, so let's go back to this configuration. So I think, no, does anyone remember how you get config to list what your configuration is?
It's git config -- list.
Thank you. Okay, so if you want to, before you configure, you want to see what do I have configured, you can do this git config -- list. This tells you what you have configured. Okay, so in general, the important things to configure are your name, your email or contact information. The other thing we're going to do that is just nice is the color in the user interface. It just makes things like green and red, whether things look good or you should pay attention to this thing. As an editor, by default, we recommend Nano. This is just because it's available on all platforms and it gives you little directions at the bottom about how to save and how to exit. But in the software carpentry version control lesson, I'll put this link in Slack. There is a whole list of other editors if these are editors you want. So when you write commit messages, it's going to give you an editor to write that commit message in if you don't put it on the command line. And these are all different options that you can use. So this is setting up different. Okay. And
Sorry, is it possible to put also this link on a Zoom? Because my Slack doesn't work since my computer is
yes.
ultra old and doesn't support Slack anymore. Thank you.
And then this is, you would put this has to do with like how the ends of lines are handled, and so that they don't show up as different between Mac and Windows. So on Macs or Linux machines, this is the line you will use. On Windows, this line. And then the final thing is that the default name of our default branch is going to be main. We'll set that to main. So let me also share these slides on Zoom. Okay, so we're gonna have our first experiment with the poll. I'm gonna relaunch this poll. Please give me an I'm done when you have finished configuring your computer. This is something I'm gonna wait till everyone responds. Wait. Yeah, okay. Okay, is there anybody who needs more time? Okay. That looks like everyone. Awesome. Thank you guys. That poll worked great for me. If I can. Okay. So I think we'll keep doing that. Okay, so we've done this, we've done that. Okay. So now we're gonna start actually creating files and tracking the changes in our files. So to create a file, let's see, I'm gonna put this on the side so that I can have my, take this. Okay, hopefully we can get everything side by side. So we're gonna open up a text editor. Again, I'll be using Nano. You can use your favorite editor. We just want the file saved in this directory. So I'm gonna type Nano. That opens up a text editor. In that editor, this is gonna be about Mars. So I'm gonna type cold and dry, but everything is my favorite color. I'm Dracula here. And then I'll save this file. So you can see here that Nano actually gives you directions on how to save things. And so if I do Control O, that asks me for a file name. I'm going to call this mars.txt. And then if I hit enter, that wrote it out. And then I can try Control X to exit. So again, Control O, type the file name, Control X to exit. Okay. So I've created this file. Now I can use my favorite git command. What is my status? So what this tells me is, again, I'm on my main branch. There's no commits yet, which is true. We haven't done that. It tells me I have an untracked file. It's made this file named red to tell me it's untracked. Git also often gives you the command it thinks you probably want to do next, which is git add. So that's actually how you tell Git to start paying attention to the file when it's an untracked file. So that's what we're going to do, git guessed right. So we'll type git add mars.txt. Now when I type git status, you can see it says, oh, this is a new file you've told me to track. So we have told it to pay attention to this file, but we haven't actually saved a snapshot of the current state. The way we do that is with the commit. So Git is different from some other version control in that there's a two-step process. The first thing is you add it, and this allows you to add not just one file or all files, but possibly a logical grouping of some subset of your files if you want. That puts it in what's called the staging area. And then once you have everything you want there, you can commit all of those changes with a single commit message. And a commit message looks like this, git commit. For now, we're going to be writing commit messages on the command line, which means we'll use the -m saying the next thing I give you is going to be a commit message. If you have a longer commit message, you can do it git commit without this -m, and it'll open up a text editor that you can write that message in. And so I'm going to say starting to think about Mars is my commit message. Okay, so when I exit that, you can see it said you've made a change, you've added a line, is this file mars.txt. Now when I type git status, it tells me that I am on my main branch and everything is clean. I haven't made any changes since my last commit, so there's nothing to commit. Are there any questions about this process? Okay, so what are we actually doing? You have your file, you're changing, you're adding a line, or in this case, we're creating a new file. When we add it, we're adding it into our staging area. You can think about this as if you're building a still life and you're setting up the still life. So before you take the picture, you got to put everything you want in that still life. You got to set the scene. And then once you've set the scene, you use git commit to actually take a picture of what you have in your staging area. So for these exercises, we're just going to be adding one file at a time to our staging area, but you can add any number of files you want to your staging area. So if you have a change that moves across 2 or 3 different files, but it's kind of the same change, you can group that change in those 3 different files in a single commit message. And then once you make that commit, you're saving a snapshot of those files at that moment that you can then go back to at any time. Any questions? Okay, so your first exercise is you're going to create a file called jupyter.txt. You're going to write a sentence about Jupyter. And then I want you to start tracking it and record the current state of jupyter.txt, just like we did with mars.txt. Instead of putting up your post-it, I'm going to relaunch the poll so that you can tell me when you have finished this. So in general, my philosophy for exercises is I'm not going to wait till every single person is done, but when most people are done, I will then do the exercise with you, and anyone who hasn't finished can finish up with me. Okay, so most of you have finished this, or at least more than half. So I'm going to use Nano to create a file. My comment for Jupiter is the moons might be a problem for Wolfman. And then I am going to save this as jupiter.txt, and then I will close it. If I type git status, I can see I haven't tracked that file. I'll type git add jupiter.txt, and then I'll type git commit, writing my commit message on the command line. I'll say node. So one thing to note here is that I'm putting my commit message in double quotes, which means I can use a single quote inside it. But if I had used the double quotes, that would have closed the quote. Okay, so now if I type git status, I can see everything looks good. Okay, how's this going for people? Are there any questions? I have about 3 people who haven't finished yet. Do you have any questions? Okay. So the next thing we're going to talk about is, so you have a project, you're making all of these commits. How do you see the history of what you've done to figure out if you want to go forward or backward? And you can do this with git log. So if I type git log, you can see my 2 commits. So you can see this is where the configuration comes in handy. You can see who made those commits. For us, just working locally on our computer, the commits hopefully are just made by us. But you can imagine if you're working on a group server, different people will have different authorship, and you can see commits by different people. You can see the date the commits were made, as well as the commit messages themselves, and it's in reverse order. So the newest commits are at the top. Once you have a more robust history, you probably don't want to look through the entire history. And so what I very commonly use is you can do git log -n and just say, show me X number of commits. And so if I say, just show me the last commit, it'll just show me 1 commit. If I said, show me the last 2 commits, it'll show me the last 2. And so you can imagine if you had 100 commits you didn't want to page through, you can use this to just look at the last few. The other thing is that we will be using this very soon, is each commit, notice, has this like super long commit hash. This is how Git keeps track of any changes I made uniquely from any changes you made. You can imagine if every commit, it was like, well, this is commit 1, this is commit 2. And then when someone else is working on their computer and they had commit 1 and commit 2, when we tried to combine those, we both have commit 1s. So this is unique to your computer. In practice, you don't need this huge string. The first 7 characters should uniquely identify each commit. So we'll be using that in a second to identify the commits if we want to go back and forth. Okay. So the next thing that we want to do is make a change to our files. So now this is kind of like the normal process of working. You have files. Now you're like, oh, I'm going to add another thought. All right, so I just put this in Jupyter, but we can put it in our Mars. So let's look at our Mars file, mars.txt. And we're going to add the 2 moons may be a problem for Wolfman. Now I'll type Control O to write that out, Enter to write it to the same file name, and then Control X to close. So I've edited mars.txt. If I type git status, it tells me now, instead of saying this is an untracked file, they've just said you've modified this file. If I want to see what changes I made, maybe it's a couple days later, maybe you don't remember you made these changes. If you type git diff mars.txt, you can see the new line we've added, and git nicely makes this green and adds the little plus next to it. So it's saying you have added this to this file. So now we know the change we've made. If we're ready to save our snapshot, we can add this to our staging area. We do this with git add mars.txt. So now if I type git status, you can see that that modified file now has been added to my staging area. It's green. So it says these are changes to be committed, whereas up here, it said these are changes that have not been staged for commit. Again, they give you things you might want to do. So here it's saying maybe you didn't want to stage this. This is how to unstage the file. So this is how to just return it back to being modified. And then under the modified, it says you either want to add this to your staging area, or you want to discard your changes and go back to your last saved version. So we want to save these changes. So what we want to do is type git commit -m, and my commit message will be concerns about Mars's moons. So now I can type git status. I can see everything's clean. I have no new modified files. If I type git log, I can see my 3 commits. I will say, sorry, git log, if you have a longer log than fits on your screen. So here, let me make mine smaller. If I type git log, it puts me into like a less more terminal. And so the way you can page through this with shift, and then to exit, you type Q. Okay, so what we just did is, instead of adding a file for Git to track it the first time, we edited our file. This is kind of my working visible file system. And then when I was ready to save it, I added it to my staging area saying, I'm ready to save a snapshot of this file. And then I saved the snapshot using git commit. Are there any questions at this point? Okay, so your next exercise, open up Jupyter.txt, add a line, view the changes you made, record your changes in the project's history, view your project history, and then tell me using the poll, which I am about to relaunch, when you have finished this. If you finish early, there are a couple things you can try. You can make another change, try committing without adding. This will give you, this will put you in the editor to write a commit, or sorry, this will give you an error. You can also try viewing changes between adding and committing. Will you be able to see anything? And then try committing without -m. So go ahead, let me know here when you've finished. And then if you want to start these, we'll go through all these together when most people have finished this exercise. Okay, let's look at this together. So I'm going to open up Jupyter.txt. I'm going to add a line. Can't wait to see the giant red spot. And then I will close this. If I type git diff, I can see the changes that I made. It's better practice to actually give the file name. Git diff gives you every change you've made. So if you have multiple files, you see all of the changes. So I can see that I added this line. To record my changes, I'm gonna git add Jupyter.txt. If I type git status, I can see that I've staged that to commit it. I'll type git commit -m note about the red spot. Okay, so that was the basic thing. This may start feeling repetitive to you, and that's my goal. I think when people first start to learn Git, at least this was my experience, things felt like I could break things and I wasn't totally sure what the workflow was. So my goal of this section is to just get this basic, make changes, add, commit, make changes, add, commit, figure out what I've done, make that feel like boring and very standard to you and routine. Okay, so there were a couple other changes I said we could make. So let's look back at our file. Let's see, what can we say? Maybe we can see volcanoes. Okay, so I've added this note. I'm going to save it to Jupyter.txt. Okay, so the first thing is try committing without adding. Let's say I type git commit -m volcanoes. So you can see that what it has done is Git said, this doesn't work. You have changes that haven't been staged for commit. So that's this message here. And then it's saying you probably either want to add or revert your file. So then the next thing I said is to view changes. So right now, if I type git diff Jupyter.txt, I can see my changes. If I add Jupyter.txt and I type git diff Jupyter.txt, I don't see any changes. So diff generally will just look at what was in your staging area last. And so because we now have moved Jupyter to our staging area, we don't see these differences. If we wanted to, there is this -- staged option. And that will then say, okay, show me the changes in my staging area. Okay, and then the final thing is, what if I just type git commit? What if I don't use that -m? When I do this, it puts me into whatever I set to be my default editor. And now I can type a longer message. So, you know, I'm thinking about volcanoes. Will we have time for the moons? You know, making more changes, whatever you want your messages to be. This can be any format you want. It can be any length you want. And then when you're done, it's the same process. You save the file. Don't try and change the file name. Just save to the default file name. Notice that's in.git, and then close. That has the same effect. So if I look at git log -2, you can see this is now the commit that I've made. So it has the same effect as doing it with -m. It just allows you to write something a little bit more verbose. Okay, are there any questions on that? Okay, so that's our basic workflow. Now we get to go into the fun stuff. So this is what we just talked about with staging. Okay, so what if I want to go back to previous versions, or I want to go, I want to see what different versions look like. So there's different ways of referencing different versions. Because every commit has this really long, complicated commit hash, Git has given us a shorthand for referencing the last version 2 versions ago. The current version you're on is called the head in all caps. So where you are is head. And then if you want to go back 1, that's head ~1. If you want to go back 2, that's head ~2. You can do that any number of commits back you want. Although after 2 or 3, it might make sense to start using the commit hashes. So these are kind of the 2 ways that you can reference different versions of the repository. You can either use head ~whatever to say, take me back 2 commits, or you can actually copy the first 7 characters of your commit hash and use that. And to get that commit hash, you'll use git log. Okay, so we can explore the changes we've made without changing our repository, just looking at the changes and trying out this different head. So if I type git diff head ~1, that'll show me the difference between 1 commit back and the current commit I've made. So I can see my volcano commit. If I type git commit ~2, that shows me 2 commits back versus my current commit. So I can see the last 2 changes I made to Jupyter. If I type head ~3, that then shows me that I've modified 2 files. So I modified Jupyter.txt with these 2 lines and Mars.txt with this line. Okay, so that's great. And you can, but let me look at my log. I'm going to say -n 2. Okay, so this gives me my 2 commit hashes. So if I copy this, the first few characters, I can also say git diff and then the commit, and that'll show me the differences between that exact commit hash and where I am now. Okay, are there any questions about that? Okay, so now that we know how to reference different versions, let's actually figure out how to recover files if we make a change that we didn't need to make. So what we're going to do is we're going to overwrite mars.txt. So the way we can, because Mars is a small file, we can just print the whole thing to the screen. So if I look at cat mars.txt right now, you can see it has these 2 lines. But now I'm going to overwrite that. I'm going to say echo, the mummy will like the dry air. And then I'm going to pass that into mars.txt. So now if I type cat mars.txt, you can see that I've overwritten what I previously had there. And if I type git status, it'll tell me that file has been modified. So if I want to recover my last saved version, I can do this simply by typing git checkout head mars.txt. So git checkout head says revert to the version that head was at. Remember, head is your last commit. You could also revert to an older version if you wanted that. And then mars.txt explicitly says which file you want to use. So we're changing mars.txt to the last version in head. So now if I type git status, You can see it's all clean. And if I look at mars.txt, you can see that it's back to being what was in my last commit. Are there any questions?
Is that any better or different than using the git restore?
Yeah. I think they are the same. If anyone here has thoughts, I think you can use either. Checkout is more universal command. So I think you can use it in more instances, but for this situation, you could use either.
Okay, thanks.
Okay, so what we're doing here is we've modified our file, and now we're saying take something from our repository and match our working files to that version. Okay, so next exercise, I want you to practice doing this with Jupyter.txt. So overwrite it, recover it, and then let me know in the pull that you're done. And let me go back to the commands we did. Okay, let's do this together if you haven't finished. So I'm going to look at Jupyter.txt. I'll say maybe we can spot the Juno spacecraft. I'll overwrite that and exit. Oh, that's not at all what I wanted to do. Okay, sorry. Echo. Okay, so I've overwritten Jupyter.txt. If I cat Jupyter.txt, I can see I've fully overwritten it. So now to get it back, I'm going to type git checkout head Jupyter.txt. Now, if I look at git status, everything looks good. And if I look at Jupyter.txt, I can see it went to my last saved version. Okay, while you guys were doing the exercises, I also looked at git restore versus git checkout, because it used to be that when you typed git status, it recommended git checkout. This is so when Git first came out, it was known for being very unfriendly to beginners. And there were a lot of commands that kind of did a lot of different things. So git restore is a more specialized command that's like very explicit about what you're doing, but it's not fundamentally doing anything different. So it's just a new command that Git has introduced to try and make things a little easier. So you can use either git checkout or git restore. Okay. So I think we're almost at the end of this lesson, and then we will take a break. So a couple other things. You can use git show to look at changes and commit message. So you can think of this as like, show me what I did in this commit. So if I type git show, you can see that I can see both the commit message as well as the change that I made. Whereas when I type git diff, I don't get the message as well. You can also type git revert and then a commit hash to undo that commit, and it creates a new commit instead of just undoing what you had previously done. Instead of, sorry, what do I want to say? If you use git checkout to go back and forth to different versions, let me take a step back. Okay, so we talked about what happens if you want to recover a new version. What we haven't talked about, and I don't know where the slide is what if you want to go restore, let's say, a previous version. So if I type git checkout, or let me actually look at my log. Git log -n3. Okay, so my last 3 commits are Jupyter, Jupyter, and Mars. Okay, so let's say I want to look at Jupyter, but look at how the Jupyter was before I added my note about volcanoes. So I can type git checkout. I'm going to use the commit hash, this commit hash. And then I'm going to give it the file name. It's important that you give it the file name. Okay, so if I look at git status now, it says that the file Jupyter has been modified. It hasn't, and it's been staged for commit, but it hasn't actually been committed yet. So if I look, let me just use cat. If I look at Jupyter, you can see that the line about volcanoes has been removed. So if this is where I want to save it, I'm like, I want this to be what my Jupyter.txt file looks like now. So let's say I made a change, I committed it, and then I realized that was a mistake. What I can do now is I can type git commit -m, removing volcano comment. And that then makes a new commit. So now if I look at my log, what you can see is that my history, and this is why I said Git makes it hard to delete things, is I added a note about the red spot, I added a note about volcanoes, and then I removed my note about volcanoes. So I can see that whole history of the process. Git revert just reverts to that version and creates a new commit automatically. If you when you did check out, you didn't include a file name. This puts you in a detached head state. So let me show you what that looks like. So you get this kind of scary note that you're in a detached head state. What does that mean? And it basically means that your whole repository is kind of, you have things going in this direction, and Git isn't really sure what to do with where you are. It doesn't know where to put things. And so to get back out of a detached head state, you can type git checkout main. If I type git checkout main, that just puts me back at the head position of my main branch. And so now if I look at git log -n3, you can see I'm back to where I was. I have my volcano comment. I have my my whole history of Jupyter.txt. Okay, so those are different ways of navigating your history, of going back to previous versions and using those previous versions, or also backing out changes that you may have made that you no longer want to make. This is everything that we're going to do for local Git. Are there any, the next thing we're going to do is we're going to move to collaborating with ourselves, maybe across different machines, or just putting our work out on GitHub to make it public. Are there any questions before we leave our local Git? Okay, let's take a 10-minute break. So we'll meet back at 20 after in whatever time zone you're in. During that break, the only thing I ask is that you check to make sure that you can log into your GitHub. So I want you to go to GitHub, and you should be logged in as you here. If you're not logged in, please log in and try and remember your password. I'm going to take a quick break, but I'll be back in less than 5 minutes if you have any questions or want to chat about anything we've done until then. Otherwise, I'll see you back in now 9 minutes. Anything on any kind of remote server. We don't need, like, everything that we've done, we haven't needed an internet connection for. No one can see it, and if we wanted to get rid of it, we just delete that .git directory. It all goes away. Okay, but I think one of the powers of Git is its ability to allow you to collaborate and to share what you've done in a public way. Or in a private way, depending on how you want to collaborate. So we're going to be using GitHub. This is a server that basically stores everything. So we're now going to talk about our local repository. That's what we have on our computer. And then a remote repository. So this is a version of our repository that lives on a remote server rather than on our computer or our collaborator's computer. It's a central location that everyone can see. So I can look at it, my collaborator can look at it, my desktop at home can look at it, my desktop at work can look at it. This remote repository is kind of one central location. It requires that you have some way to connect to this remote repository, whether that's internet or some kind of internal network. GitHub is come to be kind of the de facto default, but it's not the only option. There's also Bitbucket, and there's also ways that you can set up your own server. And the software carpentry version control lesson has a section on this. This remote is it remotes hosting on like different options you have for hosting, but we're going to be using GitHub. Okay, So the idea is you have your own local copy. So this is everything we've been doing. We modify our file, we add it to our staging area, we commit it. But then there's this extra piece that we then can take our repository and we can push it to a remote repository. And this now creates something on GitHub in a repository with the same name. There's also questions of whether you want your default repositories to be public or private. GitHub and Bitbucket have very different models for this. GitHub, the default is public, but if you have an education license, which you can get at a research institution, then you can have private repositories. And so that allows you to have both. And you can also turn private repositories public. So you can imagine you're working on a paper, but you haven't published it, you haven't finalized your results yet, but you still want to be able to share with people. You can make this a private repository. And then when your paper gets published, you can turn it public and allow everyone to see the work that you did to produce that paper. So that's the remote repository. So the first thing is I want you to sign into GitHub because we're going to be using this. Let me restart our poll. And please let me know when you have successfully signed into GitHub. You will know that you're signed in because your name will be here. And then, yeah, let's just start with that actually. Okay. Does anybody need more time? Raise your hand. Okay. I think we will call that good. Okay. So the first thing we're going to do is we're going to set up SSH keys. But to do that, we're going to then first check whether we have SSH keys set up. Okay, so in your terminal, what I want you to do is type ls-al/.ssh. If this exists, then you will have files printed. If you get something that says no such file, then I want you to create your SSH key. You can do that with this command. This -t just says which type of like algorithm is used to create the key, and then -c is your email. Save it to the default file. If you're doing this on a server, you can set the passphrase. If you're not, you can just hit enter. Okay, so relaunching the poll. Please let me know when you have when you can type ls-l and see something that looks like this, an ID-ed and an ID-ed whatever .pub. Those are the two files that we care about. So once you have generated your SSH keys and you can see a file that looks like this, please give me a yes. If you have questions, now is a great time to ask them. So what this does is we're creating a file that has, we're creating like a secret handshake that we will give to GitHub so that GitHub knows that this is our computer. We'll give it our unique public key. And this will allow us to interact with GitHub without always having to enter. GitHub actually made it so you can't enter a password without having to set something else up. This is a way of authenticating your computer. Yeah, Carrie.
If I do like the for the key, if the email in there is different from the email with my GitHub, or should I
Doesn't
change that
matter.
too? It doesn't matter. Okay, cool. Thank you.
Mm-mm. Any other questions? So don't forget to answer the poll when you're done. I think we're waiting on about 4 people. Yeah, sure.
Yeah, me and Catherine in the chat, we have keys that are like ID RSA.
Oh,
Are
that's
those
fine.
fine?
That's fine.
Okay.
Yeah. Okay. Don't forget to fill out the poll. Missing 2 people, I think. Okay. Excellent. Okay. So I'm going to have you, we're going to do cat tilde slash dot SSH slash ID, whatever your algorithm is, dot pub. So this is your public key, and we're going to print it to the screen. It's going to look like this. It starts with SSH. It'll end with an email. Copy that whole thing. Okay, we're going to put them, we're going to tell GitHub about our keys. So we're now going to go to GitHub. And we're going to go to our name and settings. So once you get to settings, on the left, there's this SSH and GPG keys. If you press that, you can add a new SSH key. You can type something to remind you of which computer this key corresponds to. And then here is where you will paste that key and then press add SSH key. Okay, I'm gonna relaunch the poll. Okay, so let me know when you've done that. So again, you're gonna go to your name, you're gonna go down to settings, you're gonna then go to SSH and GPG keys, you're going to add new SSH key, and you're gonna paste your public key in here. And then you're going to let me know when you have added that. And then you can test that this is working with this SSH-T git at github.com. So this is SSH-T git at github.com. And you should get something that says you've successfully authenticated. Don't worry about the shell access thing, that's fine. Okay, we're still waiting on 3 people. Let me know if you have questions. Okay, that was the hardest, most boring part of the lesson. Okay, so now what we're going to do is we are going to create a remote repository, and then we're going to connect this repository to our local repository, our local planets repository. Give me one. I just realized I forgot. Okay, well, we can do this here. Okay. Okay, so in Git, under this plus button, there's this new repository. Click that. You shouldn't have to choose the owner unless you're part of multiple organizations. You can just make it your default Git if you have that option. We're going to call it planets. Give me 1 second to just delete my planets repository. It makes it hard to delete a repository. They want me to authenticate my GitHub. Okay. Sorry about that. Let's get back. Okay. So we went up to the plus. We made make a new repository. We're going to call it the same name as our local repository. It doesn't have to be the same name. You can call this whatever you want, but for your peace of mind, I recommend that you make them the same name. It just makes it easier to know what corresponds to what. You can set a description if you want. You don't have to. We're going to make it public, but this is where you would switch between public and private if you have the option to make it private. Again, this depends on repository type. We are not going to initialize with a README or a git ignore or a license, but this is, you can do all of that. It just makes it, those are things that you tend to do when you don't have a local repository yet, when you're going to create the remote and then make a local copy of it. Okay, so you've done, that's all you're going to do, and then say create repository. So this now takes you here. If we hadn't done anything yet, we had no local repository, we would copy and paste this. But we do have a local repository, so we're going to do this. And this is what this is going to do is it's going to add a link to this URL, which is the URL of our repository. If we look up here, and it's going to give it this nickname origin. And what this means is that instead of remembering this URL and typing it right every time, we can just type origin. Origin is a convention, but I recommend sticking with it. And then we're going to, I think this renames our main branch main, and then we're going to push that branch to GitHub. So copy and paste this into your terminal. You can make sure that we're in our planets directory, and you should be able to just copy and paste this whole thing. Oh. I think this isn't going to work. Hold on. Yeah, okay. I actually, oh wait, sorry, I did something wrong. Up here, change this HTTPS to SSH. So we set up our SSH keys so that we didn't have to deal with that authentication thing you saw. The difference you'll see is that this URL and this URL here, instead of starting with HTTP, starts with GET. Okay, so now try copying and pasting that in. Oh, hold on. Sorry, okay, that should work. Let me reopen our poll so that you can all tell me if that has worked for you. So, again, we switched this from HTTP to SSH, and then we copied and pasted this in. And so go ahead and let me know when that worked, and let me know if anything is going wrong for you. If you had copied and pasted the HTTP, and now you're getting an error, the thing is that it added origin already pointing to HTTP, so you have to remove that remote so that you can re-add it with the SSH. So I did that with git remote remove origin.
So if we do the git remove origin, how do we get back that original command with the SSH? I guess.
Do you have it here, or does this, what did this web page go away?
That goes away as far as I can tell.
Okay. If you up arrow this command, you should be able to just modify this URL to get at git. Let me just double check that. Git at, and then you do that, and then here instead of the slash, that should be a colon. Does that work for you?
Stand by. Yeah, actually, I think under the code button, you can get that string, I think.
Yes.
Okay.
Okay. I'm still missing 2 people. Are there other questions? Okay. I'm still missing 2 people. I'm hoping that just means you haven't clicked it. Please let me know if you have questions. In the meantime, everyone, if at the top, I think, of your screen, you should see something that says like your username / planets. If you click on that, it'll just take you to kind of your home repository website. And here you can poke around. So explore a little bit, see what things do. It was already pointed out that this code button here gives you these URLs. You have the HTTP and the SSH if you need to clone again. You should be able to see your 2 files. You can click on them and actually look at what's in those files. You can look at blame to see who edited those files. So go ahead and poke around for maybe another minute, and then we'll come back. Okay. So we're now all set up to actually use our remote repositories. Let me get back here. And the poll. Okay, so let's go back to our command line and let's just check in with where we are with our remote or with our local command line repository. Now that we've made this remote repository, we've connected things to it. Okay, so if I type git branch, this tells you which branch you're on. In the next section, we'll talk about different branches. But this is, right now, you should just be on default. There should just be one branch. And it should be called main at this point. We created this remote repository. I'm sorry, we created a link to our remote repository. If we want information on that remote, where is it pointing? Do I have the URL right? What did I call it? you can type git remote -v, and that tells you that origin is pointing here. For now, that's all you should have here. We've given it the nickname origin again, so we don't have to type this. And this is telling us that there's kind of two different things we can do. One is fetch or pull, and that is taking things, changes that have been made at the remote repository and bringing them to our local repository. And then there is pushing things, which is taking changes that we have made at our local repository and putting them on the remote. And so it's just differentiating these two. We want them to point to the same place. I actually haven't encountered a situation where I've made these different. Okay, so let me think. Okay, so the next thing we're going to do is we're going to put you all in pairs in breakout rooms. And you are going to do a collaboration. But first, I want to talk you through what you're going to be doing. And the different steps you're going to do. And then the helpers and I are going to circulate through the different breakout rooms and check in with where you are. Let us know if you have any questions. So I put a link to these slides in the Zoom chat. So you probably want to bring that open because there's very detailed directions that I want you to follow exactly. So what we're going to be doing is one of you, you're going to decide who's Dracula and who is Wolfman, and you're going to use Dracula's repository. So then I want you to talk to each other on Zoom. So I'm not going to assume everyone has Slack. You'll be in a breakout room, so it should be pretty easy to say hi to each other. Decide who's Dracula, who's Wolfman. You'll use Dracula's repository. And then Wolfman, what you're going to do is you're going to clone Dracula's repository. And so to do this, I want you to leave your repository and you're going to create a new directory called Planets Collab. So this is so that you don't create a repository within a repository, which things get complicated. So you're going to make this collaborating planets repository. CD into that directory, don't forget that. And then you're going to clone Dracula's repository. So you do that, Dracula will tell you how to get to the URL to get to their repository. It should be github.com/their username/planets. And then make sure that when you go to that code button, you select SSH. And you're going to clone that. This is going to create a planets directory inside your planets collab directory. And you'll CD into that planets directory. Okay, so that's Wolfman. Dracula, you are going to then have to add Wolfman as a collaborator. So you go into your settings. For your repository, there's an option for collaborators, and then it says find a collaborator. So Wolfman, you'll tell Dracula your GitHub username. Dracula, you'll enter this, you'll invite Wolfman, and then Wolfman, you'll get a notification in GitHub as well as probably an email that says that you've been invited to join this repository, and you'll accept that. So at this point, Wolfman, you have a local copy of Dracula's repository. So you guys now both have repositories that point to the same remote repository. And it's Dracula's remote repository. And you both have permission to write to that repository. We'll look at when you don't have permission to write in the next exercise. Okay, so now that you've done that, this is kind of what I just said with my hands. You both have your local repositories, and then you're going to be doing things where you're pushing things up and pulling changes down from this universal remote repository. And we're going to do 3 different types of collaboration. So the first is just you edit, is that one person's going to edit the file. They're going to put it on the remote repository. The other person is going to pull down that change to their local repository. They're going to make the change, another change, and then they're going to push that up to the remote repository, so that the other person can change it down. So you're both making changes, but you're not making synchronous changes, but you are still getting the other person's changes. The next thing that you're going to do is a merge without a conflict. So here, you're both going to modify the same file, but you're going to modify different lines of the file. And you'll see that what Git does is it merges these two together. So you'll get a note that you're merging in different changes, but it doesn't ask you to choose which one, or you don't get what's called a conflict. It just merges them. You will only see the merge if you're the second person to get the change. Because the first person just combined with the remote repository and there was no difference there. Okay, then the last thing that we're going to do is we're going to merge with conflicts. So this is the situation where you and your collaborator edit the exact same line of a file. When you do this and you try and pull in the change that has been made, you'll get something that says there's a conflict. So you've made a change. You have added and committed it to your local repository. Your collaborator has made a change to the same line of the file. They've added, committed it, and they push it to the remote repository. So you now try and pull in those changes. And what happens is you get a conflict because it says you both modified the same line of the file. When you look at the file itself, you'll see something like this. So you'll see head, and then your changes, dash, 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 and then this is the things that should be merged in. In many ways, Git is smart, but here I think it's kind of dumb. Git says, edit this file to look exactly the way you want it to look. So you have to delete this line, and this line. It's up to you if you want to keep both changes, if you want to keep just your change, if you want to keep just Wolfman's changes. It's your choice how you edit this file. But once you've edited it and definitely deleted these things, Git does not remove those. You will save it, add, commit, and push. And then you'll repeat this. Okay, so these exercises have been designed so that you encounter all of these different situations with the minimal amount of changes. So you need to follow them exactly, and everything should work out the way I said. One thing that I want to say is the way Git works is it never wants to try and merge things at your remote repository because that's kind of a pristine thing that everyone's looking at, and they don't want it to be left in this weird state of like, oh, there's a conflict or something like that. So it will always ask you to pull in any remote change, resolve any conflicts, make any merges on your local machine, and then let you push to your remote. So it never lets you push to your remote if there are any changes on your remote that you don't have locally. Okay, I know that was a lot. I'm going to put you in breakout rooms, and then start circulating, or the helpers and I'll start circulating around. And you can start working your way through. Is there anybody who hasn't found the link to these slides yet? I expect you to both have them up and to be working through them together. Are there any questions?
Not a question, but a comment, since
Yeah.
we have, I think, 3 helpers, me, Azalee, and Angelka. And we have 10 participants, so we cannot just assign one helper per each room. So if for some reason you have some complications and there is no helper in your room, ping us on Slack, because it's the place where we are most likely to check it in time, and we will come to you.
Okay, I'm gonna create these breakout rooms, and let's see what happens.
Well, there are already 5 breakout rooms. We just have to assign people there.
Okay, wait, I hold on. I think I think I'm gonna create them and assign them. Are you assigning people to rooms already?
No, no, no. You can go on.
Okay, I'm only seeing, okay, we're actually gonna have just 3 breakout rooms, so that's perfect.
3, why not 5?
Because people have left.
Oh, yes. Okay.
Okay. Angelica, I'm putting you in breakout room 4, and you can just stay in that room.
Okay.
And then, Alex, do you want to go to breakout room 3 and I'll go to breakout room 1?
Sure.
Okay. I've opened all the rooms. Oh, wait, I have to.
But we have also Shar and Willow not
I
assigned.
see. I'm creating a room to assign them to.
Mm-hmm.
Okay,
Okay.
that worked.
full. You're super muted right now. Also, it's recording.
Oh, right. Yeah, yeah. Good call.
Hey everybody, welcome back. Let's see. Let me check in and ask if there are any questions. There are a couple things I want to talk about, but I want to check in because this is something that normally you'd all be in a room and I'd be walking around, but it wasn't quite the same situation. And so we weren't able to walk through things quite as in quite the same measured way. So are there any questions about what we've just done? Okay, so two things that I want to talk about that came up before we move on to anything else. The first is that some of you guys got messages about setting rebates. So it asked you to do something like git config pull.rebase false, and it gave you a couple different options. There was fast forward. So this has to do with how Git merges things and preserves the history. You don't need to worry about this. It used to be set to this, the first option in that list by default, the config pull.rebase false. So you can set that if you were asked to set that and not worry about it any further. But I just wanted to mention that. The other thing that I wanted to talk about is, we checked our different branches, we checked our remotes, but you really frequently typed something like git push origin master, origin main. And this is saying I want to push from my to origin and main branch from the branch that I'm on. So Git always assumes you know where you are. And so anytime you specify a branch, it's not the branch you're on, it's the other branch. And then similarly, when you type git pull origin main, you're pulling from origin's main branch. When things are set up right, you don't need to type, these are both origin and main are both the default. And you don't need to type, you can type just git push or git pull. I like to type the branch and the remote to be really explicit. So I type this every time, but you will see people who don't. Okay, any questions?
A little comment. So if you have a project with a lot of branches, until you get used to it, it's better to do git branch and see the list of branches, because if you are doing git push and specify a branch and then specify the wrong branch, you may be unhappy with the results. So in this regard, git push and git pull without specification of where you're pulling it or pushing it to or from is somewhat safer.
Yeah. Okay. So we're going to step up the level of difficulty one more now. And we're going to go to our final exercise, our final lesson. So let me put this link into Zoom and into Slack. And then, okay. So now we're going to talk about how do you collaborate, if I can find it, how do you collaborate with people who you don't necessarily trust? Maybe you don't know them. Maybe you want to collaborate on a project that's a really big project. So say you found a bug in AstroPy, you want to contribute to AstroPy. They're not going to give you write access to the whole repository. They want a little bit of regulation about what you do and when. So we're going to talk about now, how do you contribute to a project that you don't have write access to? So someone hasn't added you as a collaborator, but you still want to contribute to this project. So I will be the project owner, and then you guys will all be contributors. And so I call this the open source workflow because in open source coding, this is usually the situation you're in. You don't have write access, but you're the community as a whole is contributing to a project. Okay, so this is a complicated figure. We're going to walk through this step by step, but I just want to give you an overview of what we're going to be doing. So you have so I have my repository on GitHub. So when I say my, that's me, Azalee. You are going to make your own copy on GitHub. So you make your own remote repository on your GitHub account. It's still remote. Your local computer knows nothing about this, but you now have your own remote copy. This you have rewrite access to, and that's the key piece, is that you can now clone your copy of my repository onto your local machine. And now you can make whatever changes you want, and you can push and pull those to your own copy without my copy knowing anything about it. Okay, so to do those changes, what is recommended and highly, highly recommended is that you create a branch. This is essentially a parallel version of the repository. Git does a great job of keeping track of what have you done in one place and what have you done in another, but it allows you to create an entire parallel copy of the code that doesn't overwrite anything that you already have, and that you can switch between the two. So you'll make a branch on your local machine. On this branch is where you make all your modifications. It's where you add and commit things. So they all get added and committed to this parallel copy. And then you will reverse things. So you've now made all of your modifications. You're ready to tell me about the changes you've made. So the first thing you want to do is, if I've made any changes to my repository in the meantime, you're going to merge those changes in with your code so that your code has your changes plus the latest version of my code. Then you're going to take any new changes I have plus your changes, and you're going to push them to your copy of my repository. That's where you have write access. And then from there, you issue what is called a pull request. And this is a request to change my code that I can then review. I can look at the changes, I can test the changes, and I can decide if I want to make those changes. If I do, I accept the changes, and I do what's called merging the pull request into my remote repository. So this is the workflow that we're going to be going through. Are there any questions about that? Okay, so the first thing we're going to do is you're going to fork my repository to create your own remote copy of my repository. Okay, so this is your first exercise. Go to this URL and press the fork button, and then let me know. I'm going to restart our poll. Let me know when you have forked it. So what you should see is you should see now your GitHub username, and then this this repository name. So instead of my name, your URL will be this once it's successfully forked. So go ahead and do that, and then let me know. If you have any questions, anything's come up, like the last section, this is going to be very cumulative. So if you need help, let me know.
Did you want us to go ahead and create the fork or just click?
Oh, press the fork button, create the fork.
Okay, cool. And it just, and there's a thing that says copy the main branch only, and that's good to be checked.
Yes. There shouldn't be another branch, but yes, that's fine to be checked. Okay, I only have about half of you that have said you're done. Are people stuck somewhere?
I think we are done.
Okay, I still have 2 people who haven't told me they're done.
One, I mistakenly closed this poll without voting, so
Okay,
sorry
okay.
about this.
If you're not done, can you raise your hand? Okay, we're gonna move on. Okay. Okay, so the next thing is to download your own copy. We're gonna clone this. So come back here, type PWD. Chances are you're either in Planets or you're in Planets Collab. We don't want to make a repository within a repository. So let's go back to our home directory before we clone. So just CD, PWD, make sure you're in your home directory. You are not in Planets or Planets Collab. And then you're going to go to, you want to clone your copy of my repository. So you should be where you are, where it has your username, and then, sorry, it doesn't say code review ADAS, it says code review, and then the year, the date, and LSST. And then go to the clone download button, make sure SSH is checked, and then here you can type git clone and then paste the URL. So for me, that will look like uh-oh. Oh, I know. I'll go here, I'll make sure it's SSH, I will copy that and then paste. And then the final thing is to actually CD into that directory. So CD into code review.
Sorry, can you repeat where I can find things that I need to copy on GitHub?
So there should be a little green button that says clone, download, or code, maybe. So it'll be, the URL
Cool.
will be your username / code review. It's the repository you forked. And then, where did that go? Yeah, this button here.
Yes, I found it. Thanks.
Okay, so once you've cloned it, then you're going to CD into that directory. This is important. Okay, I'm going to open up this poll one more time. Let me know when you have successfully cloned. Okay, I have 2 people who haven't. Can you tell me what's going on? 1 person who hasn't. Everyone's done it. Yay. Okay. Okay. So the next step is to make a branch. So what we've done is you have made your own remote copy of my repository. You've then made your own local copy of my repository. And now we're going to create branching. Okay. So a little bit of motivation for branching. Before version control, in the dark days before version control, when you wanted to make a change that could break everything, you duplicated the entire file. So maybe you called this document 1_v2 if you were being very organized. And then you modified v2, and if that works, then that became the code that you used, and doc1.py was deprecated, and you had to remember that there were multiple doc1.py files. Challenges of this: you have multiple copies. If you make changes in both copies, that can be challenging. You can imagine, let's say you're implementing a big feature, it's going to take you a month to implement, and then you realize that there's a bug in your original code. Now, do you fix the bug in the new feature, which may or may not work, or do you fix the bug in the original document? And then how do you combine these two? What does v2 mean? Do you know what changes you made? Do you know which version is the final version? And now you have all these different files. Do you keep doing v3, v4? Is there any overlap? How do they order? All of these are complications of just creating a duplicate file. When you create a branch, what you're doing is you are creating a parallel copy of the code. You can bounce back and forth between them, and you can merge them just the way you merged your remote repository when you were working with a collaborator. So you can now combine changes on either branch, your main branch, your new branch. You can call your new branch something descriptive. And you can continue development on your new branch, periodically merging it if you want. You can merge at any point, and you can merge your main branch into your new branch. So let's say you make that bug fix, you can make sure your new branch has that bug fix while you keep developing. So that's branching. You can have as many branches as you want. You can have branches that you're working on in parallel. So you could have, maybe you're implementing a new feature, but then you thought of something else that would be really quick you want to do. You can have as many branches as you want. It's really easy to merge at any time. You can descriptively label your branches. Okay, so how do you create a branch? You create a branch by typing git branch and then the branch name. And then you switch to that branch. So that creates the branch, but it doesn't it doesn't switch to the branch. To switch to that branch, you then type this git checkout, the branch name that you gave it. Okay, let me see. So this is a workflow. You can basically, you don't need to do this right now because I'm going to give you a place to do an exercise, but you create a branch called feature with git branch feature. Then you would check out that branch with git checkout feature. Then you would make whatever changes you want. You would type git add that file name, git commit message. And then you can check back out main, and then you would merge in feature. So you check out main, so you go to the branch that you want to merge into, and then you merge, and then you give it the branch you want to merge into the branch that you're on. Remember, git assumes you know where you are. If you don't know where you are, you type git branch without a branch name, and that lists all the branches and then puts a star next to the one you're on. Okay, so I'm going to share this link with you guys. This is a really cool website that allows you to play around with all of this. So over here, you can type something like git branch feature, and it creates a feature branch. And then you can type git commit, and it creates a commit to main. You can type git checkout feature, and it switches you to the feature branch. Notice the little star is now here, and you can type git commit, like you made a change and you were committing things. So this just gives you a way to play around with things. So I'm going to copy and paste this into Slack, or into Zoom and Slack. I'm going to give you about 5 minutes to play around with this. You can refer back to this for your basic workflow here. You don't need to add here, but play around with creating different branches, committing to the different branches, switching between them, merging, and get a sense of how all of this works. So I will give you 5 minutes. I'm going to open up the poll. You can let me know if you finish early and you're just like, I've seen all there is to see. You guys take about 1 more minute. Okay. Awesome. So, hopefully you got to play around with things and feel a little bit better about having a visual for how to do things. So let me just go back here. I'm going to type git commit one more time. Okay, so you can imagine here that you have your main branch. At commit 1, you made a branch called feature. You then made a couple commits on your feature branch, so you're developing your new feature. You figured out there was a bug in your code, so you made your bug fix on main. And now you're at a point where you're ready to merge your new feature into main. So the first thing that I recommend you do is the opposite. You merge main into your new feature. Because these are different, you want to test the code as it will be after it's merged, and that is the combination of everything that's in main and everything that's in feature. So to do that, you will type, you check you're on the feature branch, and then you type git merge main. This merges the main branch into feature. So now I get this change in commit 1 in my feature branch. Now I can test that. So now I'm testing code as it will be when I make my merge. If all of that testing goes well, I can now go to my main branch with git checkout main, and now I can merge in my feature branch. This should be trivial. You shouldn't have an issue with this because you've already done that merge and everything looked good. Now you're on your main branch, you can continue making commits. If, let's say, you wanted to keep developing your feature branch, you could always go back to your feature branch with git checkout feature and make some changes and commit them again and repeat this process again. You could also go back to your main branch and create a new branch. So maybe you want to make a second feature. Then you would check out feature 2 and then start developing feature 2. So you can see how this whole process would work. Are there any questions about branching, why you would branch, before we start actually creating our own branches? Okay, we're going to immediately go to an exercise. So what you're going to do is you are going to go to your code review directory. This is your local copy on your computer. Create a new branch called refactor. Again, this is git branch refactor. Move to your new branch, git checkout refactor. Now, you'll see in this directory is a piece of code called makeplot.py. There are many errors in this code. There's many non-best practices. Go ahead and make a change that improves the code. Record your changes using git add and git commit. Remember, you can always check where you are with git branch. So let's see, I'll do this with you guys once you've had time to play around with it. So git commit, git add, git commit, record your changes, and then move back to your main branch with git checkout and merge your changes into your main branch. and then move back to your new branch. Okay. I'm going to open up the poll so that you guys can let me know when you're done. I know there's a lot of steps here. So go ahead and do these steps and let me know when you're done. And let me know if you have any questions in the meantime.
Can I ask something?
Yeah.
I'm getting a message, nothing specified, nothing added. Maybe you want to say git add, but what is this? What does it mean?
So it's saying that there's nothing in your staging area. So when you type git commit, there's nothing to commit. So it's saying, have you modified a file yet?
Yes, I modified. I changed a couple of numbers just randomly and save it, and then I try to type git add, and I'm getting this message. So
did you type the file name, git add in the file name?
of course not. Sorry.
No. Okay, so I'm gonna do this exercise with you guys so that there's a change to my repository too. So I'm in my repository, my code review repository folder. I can see that by typing pwd. I am going to create a new branch called refactor. Git branch refactor. Now if I type git branch, you can see it's created this refactor branch, but I'm not on it. I'm still on my main branch. So I can type git checkout refactor. That switches me to my refactor branch. Now, if I type git branch, it says, you're on your refactor branch. Here again, you can see the color coding that we set. Okay, so now that I'm on my refactor branch, I'm gonna look at make plot LS. Oh, I called it something different. Sorry.
myplot.py
Yeah.
without underscore.
Yeah. So here, I believe these are all actually rows, but okay, easier. There's no import statement for pyplot. Okay. So I saved that. I'm gonna check which branch I'm on. As Alex mentioned, sometimes you forget. It's always good to check. So I'm on the branch I want to be on to. I'm gonna add my plot.py. I'm gonna commit it. I'm gonna give it a commit message that's meaningful. All of this is still local onto mine. Now I'm going to merge the changes into main. So to do that, I have to switch to the main branch. Now, one thing to note is if you tried to switch to the main branch before you added and committed it, Git probably said you need to do something with the changes you made before you make me go to a different branch. And this is because it wants to know, what do I want to say? It's because it doesn't know what to do with those changes until you tell it which branch to record them on. Okay, so now I'm on my main branch. I can check that with git branch. I know I'm on the right branch. So now I can merge in my refactor branch with git merge refactor. Let me look at what these changes are. So I can use git diff head ~1. It looks like maybe my editor cleaned something up. But this is really what I'm looking for here. But it's interesting. I can see that it looks like the editor added a new line at the end of the file. Something to pay attention to. Okay. Now, okay, don't do this yet. I am going to push my main branch to my GitHub so that you guys have something to look at. You don't need to push yet. You can, you'll just have to do it again later. So I'm going to git push origin main from my branch. And now I am going to git checkout refactor. Okay, so switch back to your new branch. You're now, hopefully all of you, if you type git branch, you're on your new refactor branch. Are there any questions about this? Remember, I ask a lot of questions. Questions are good. Let me know if anything's not clear. Okay, so you have now modified your code. You've done this piece. The next thing we're gonna do, because I think we have time, is you're gonna sync with my repository. So you're gonna pull in the changes I've made. But first, you have to tell your repository about my remote. So we're gonna do another git remote add. So you're going to type git remote add. By convention, this is called upstream. And then I'm going to give you the URL to my repository. And this now can be with HTTP because you will never try and write to this repository. So I'm going to paste this into Zoom. Okay, so you should do this. Oh, not that one. Git remote add upstream and then paste that. Now you can check by typing git remote -v and you should see two. You should see origin pointing to your repository and upstream pointing to my repository. Okay, go ahead and give me a yes in the poll when you have done this. Now what you have here is you have origin, which points to your copy of my repository. And you have upstream, which points to my copy of my repository. And what this is going to allow you to do is to now pull down changes from my repository into your refactor branch. Okay, awesome. Everyone has done this. Okay, so let's make sure you're on your refactor branch. Git branch. You're on your refactor branch. And now I want you to type git pull. Now you're going to type upstream because you want to pull from my repository and you want to pull the main branch from my repository. Git again assumes you know which branch you are on. So you can type git pull upstream main, and you should get the changes I made. If you get a conflict, that's fine. You know how to resolve conflicts. Open up the file, edit the file to be how you want it to be, and then add and commit it to your branch. Okay, I'm going to reopen the poll. Let me know when you have successfully pulled from upstream main, you've resolved any conflicts, you've added, and you've committed. If you had conflicts to resolve. If you had no conflicts to resolve, you don't need to worry about adding and committing. And again, let me know if you have any questions. If you were in one of the groups who didn't get to resolve conflicts, when you open up the file with the conflict in it, it should look like this. You just delete these lines, edit the file to be the way you think it should look, save it, add it, and commit it. This is, again, only if you get a message that there was a conflict when you pull. Okay, people who haven't finished this, can you let me know where you are? Okay, so what you guys have just done is you have made a remote copy of my repository. Then you made a local copy of your copy of my repository. Then you created a parallel version of your local copy. This is where you made your modifications. So you modified the code, you added it, you committed it, you saved the snapshots with your modification. Now that you're ready to put it back into my code, you want to make sure that what you're testing looks like my code. So you pulled in any changes that I made from my remote repository. So you told your local repository not just about the remote repository, your copy of the remote repository, but you also told it about mine. And we called that one upstream. So now you're ready to push your changes to GitHub using, and you're actually going to create a new branch on GitHub. So you're going to do this with git push -u origin, not upstream, refactor. So you're going to push this to origin, and you're going to push it to the refactor branch at origin. And remember, origin is pointing to your copy of the repository. Okay. So you should get something that looks like this. You can check that that worked by going to your copy of the repository. And when you go here, these are where your branches live. You should see your refactor branch. And if you click on the code itself, you should see the changes that you made to that refactor branch. I can see my pyplot here. And then you can go back to the main branch, and those changes will have disappeared. Okay, so I'm going to reopen the poll, and I want you to let me know when you have successfully pushed your changes. Okay, awesome. Yay, everyone did that. Okay, so now the final step is to actually create a pull request. So I'm not gonna be able to, let me see. Okay, so when you looked at your repository, usually there will just be a little button, green button that says create pull request. If there isn't, then You can do it. Let me see if I can. Then if there isn't, you can go to pull requests, new pull request. Okay, either way, however you get to that pull request button, it's going to ask you, where do you want to merge from and where do you think it should be merged into? This usually is correct by default. It should be my repository and then the main branch. And then from should be your repository and the refactor branch. So if all of that looks good, let me. So then you will see a bunch of different things. So the first thing you by default see is your commits. So you're going to see the commits that you're requesting to merge. If you scroll down, it also tells you how many files were changed. So you can scroll down and see, okay, I'm adding these lines, I'm removing these lines. So this is where you make sure that the changes you're requesting are really the changes you intend to request and that nothing nefarious slipped in there that you didn't mean to get in there. This is kind of your double check. Am I asking to do what I think I'm asking to do? If everything looks good, you press the create pull request button. So go ahead and do that. I don't need to reopen the poll because I will know when you've done this because I will get pull requests. So I can already see that I have pull requests from some of you guys. If you have any questions, go ahead and let me know. Okay, so we did all that. Okay, so what you guys have done now is you've done this final, you created a pull request. So now it's up to me to decide if I like your pull request or not. But you've made your request, and this is kind of the end for you. Unless I look at your changes and I go, I don't really know if I like that. So let's say I look at, I don't know, Carrie's changes. So at my end, I can see this. I can look at the files change. That's usually where I go. And, you know, maybe I say, you know, can you add a comment? What this line does. This is totally a fine change, but I could say, review this. Maybe I request changes. If I request changes, you can make those changes locally, and when you push them to your origin refactor branch, they automatically get added into this pull request. So you don't have to worry about making a new pull request anytime someone makes a change. You just, if they ask for the change, you make the change in your local branch, on your refactor branch, you push it to origin, and it'll automatically know that this pull request is open and add it into the pull request. Ultimately, when everything, and then you can comment and you can say, okay, I updated the code to let the person know. Ultimately, when everything looks good, I can then say, okay, let's merge this pull request, and I'll confirm the merge. So that now this change is in my main branch. So if I go to my main branch and I look at this code, I thought it was going to be these lines that got replaced. Let me double check. No, it's line 22. Okay. Main. Line 22. This is the line that this is the line that we combined from being mean and then plotting it to just plotting it. So that code, now if someone clones my main branch, they get that updated change. Okay, so let's say changes are made, but now you need to update your pull requests. So what you're going to do is you're going to go back here. You're going to check which branch you're on. So you're on the refactor branch. Now you're going to pull down upstream main. So again, you're updating your branch with the new main branch. So you get these changes in. And now you can push to your origin refactor branch. So this is now going to take those changes that you made to your refactor branch and push them to your new origin refactor branch. So this means that your pull requests will get updated with these changes, and therefore if there's any kind of conflict, you will have resolved it, and I can merge your changes knowing that your code looks like what will be on my master branch. So again, I get pulled from upstream to get the changes from Carrie's pull request into my local refactor branch. And then I took those changes to my local refactor branch and I pushed them to my origin, my copy of the repository, which will update my pull request. So now if we go to pull requests, okay, who can tell me that they successfully pushed?
Should I push to refactor or to main? I just.
You want to push to refactor.
Oh, okay. Thank you.
So because you're updating the remote refactor branch from your refactor branch. Still requesting to merge it into my main, but that merge hasn't happened. Okay, somebody tell me when you have pushed.
Okay, I did.
Okay.
Can you show your terminal again, Azalee?
Yes.
It's
So I typed git pull upstream main, and then I typed git push origin refactor.
Thanks.
I'm going to move this over here. So hopefully you can see everything. Okay. So here I can see the second merge of the main branch happened here. If I look at the files, I can see that there's no difference here. Basically, like it's that this change right here, it's in my main branch, and it's in this file, so it doesn't show up as a difference. It's just already there. So the merging in this pull request that's being requested is just the changes that Miguel made, and not the changes Miguel made plus anything that I had made, or what do I want to say? There aren't. This change only adds his code. I don't have to worry about any other differences in the code. Like I have updated line 22. Okay. So that's the whole process that I wanted to show you. That's how you update your repository, and notice that that automatically updated the pull request. You didn't have to do anything like open a new pull request or anything. So that's how you incorporate changes to the main piece of code into your new feature, your refactor code, and how you ask to make changes to a repository you don't have write access to. That's everything I was going to cover. I will stick around and take questions. Let me know if you have any questions, if you want to try something out. Otherwise, I think we're done. Alex, did you have anything you wanted to say? Don't forget to fill out the poll.
Yes. So essentially, the only thing from me is indeed the poll. I will also send it to everyone because a lot of people didn't stick around, didn't manage to wait till the end. The only thing I can add is, Azalee, thanks a lot. This was a lot of information and it was an excellent job. And I have no idea how your throat is feeling right now. Thank you. That's just
Yeah,
great
you're welcome.
job.
And if you started with local Git and you went all the way through this, I would say treat this open source workflow as like, oh, I will get to that. Start with local, create a repository. You know, the next time you start a project, make it into a repository or a paper. I like to version control my tech documents. And play around with it locally. Once you get comfortable with it locally, then you can say, oh, okay, I have these slides I can look at. I've done this once. Let me look at how to do it remotely. Once you start feeling comfortable with that, then you can start going to this open source workflow when you're like, oh, you know, I found this thing that I really want to fix or something like that. You don't have to do all of this all at once. If you're very comfortable with local Git, maybe this gives you another step that you can go in another direction, or at least a language that you can communicate with people in.
That sounds like an excellent advice. So I guess I will also stick around for a little bit. So if someone has energy to finish some exercises or any questions, we are still here.
Thank you so much, Azalee.
Yeah, you're
Thank you.
welcome.
Thank
Thank you
you.
guys
Thanks,
all for
Azalee.
staying engaged
Thanks.
for this whole time.